Have you ever wondered why computers, despite being so powerful, still make mistakes with numbers? Or why we're heading toward another major computer crisis in 2038? Today we'll uncover two major hidden problems in computing: floating point precision errors and the year 2038 bugs. Let's dive in. The floating point precision problem. Real numbers are infinity. You can always add more decimal places like 3.14159 forever. But computers don't have infinity storage. They have to fit numbers into a fixed number of bits, and that's where problems start. Computers use a system called floating point representation, which follows the IEEE 754 standard. It's like a digital cheat sheet for storing numbers. It has three parts: the sign, the exponent, and the mantissa, which holds the actual digits. But this system has limitation. For example, a simple number like 0.1 point 0.1 cannot be stored exactly in binary, just like 1/3 can't be perfectly written in decimal. The result is small rounding errors that accumulate over time. These small errors can lead to big problems. For example, a floating point bug contributed to a Boeing aircraft failure and even caused glitches in classic games like Pac-Man. So, what's the solution? Use more precise data types, error checking algorithms, or libraries specifically designed for scientific computing. The year 2038 problem, a new Y2K crisis. Let's talk about another major problem on the horizon: the year 2038 bug. It's like Y2K all over again. But why? Most computers measure time by counting the number of seconds since January 1st, 1970. This system is called Unix time, and it's stored using a 32 bits integer. But there's a catch. A 32 bits integer can only count up to 2,147,483,647 seconds, which means on January 19, 2038, computers that still use 32 bits time tracking will overflow and reset to December 30, 1901. That could break tons of systems. Imagine an ATM thinking it's the year 1901 and looking your account, or flights getting incorrect time calculations. Sounds like a disaster, right? How to fix these problems? The good news: we already know about these problems, and the solutions are pretty simple. For floating point precision, we can use higher precision data types. For the 2038 bug, we can switch to 64-bit timekeeping, which extended our time tracking for billions of years. So, while computers do have a limitation, we can adapt and evolve. Just make sure your systems are updated before 2038, or set a Google Calendar reminder. Technology keeps moving forward, but so do its challenges. From floating point errors to the year 2038 bug, understanding this issue helps us prepare for the future. Thanks for watching, and if you enjoyed this video, don't forget to like, subscribe, and hit the bell for more tech insights.